So in this video we're going to be talking about the electric force, also known as the Coulomb's law. So if there are two objects, let's say this, and this is positively charged, and the magnitude of the charge, positively charged, and the magnitude of the charge is q1, and this is another object which is negatively charged and the magnitude of the charge is q2, then they will feel a force of attraction, right? Because they're opposite charges, and opposite charges attract each other. And if they were similar charges, they will feel a force of repulsion, which is also the electric force. So what the Coulomb's law states is that the electric force is equivalent to the constant K times Q1 times Q2 divided by the distance squared. R is the distance between these two objects. And this constant K is equivalent to 9 into 10 to the power 9 Coulomb squared per Newton meter squared. And the permittivity of this constant comes from 1 over 4 pi epsilon. And this Greek symbol epsilon has a value of 8.85 into 10 to the power negative 12 Coulomb squared per Newton meter squared. Okay, I'm sorry, this is not the unit actually. They're the reversed unit, so this will be Newton meter squared per Coulomb squared. Yeah. And you really need to remember this constant, because you're going to use this in every problem related to the electric force. So what does this electric force actually mean? So notice that the charges are on the numerator part of the fraction. So the electric force is directly proportional to the charges. So what does that mean? Let's say again there are two charges, and this time let's say they're both positively charged, so they will feel a force of repulsion this time. And let's say that this is q1, this is q2, and the force of repulsion is 100 newtons. So what will happen if we doubled this q2? What will happen to the force of repulsion? Since the force of electric force and the charge is directly proportional, so if we increase the charge q, the electric force will also increase. So if we double this charge, the electric force will also be doubled. So this will be 200 newtons, 100 times 2. And let's say again, let's say the charges are just like the previous one. Okay, so these are both positively charged, and there is nothing changed in the charges q1 and q2, but this time the distance is doubled, 2r. So in the previous time this was r, and we doubled the distance. So now what will happen to the electric force? Well, notice that the r, or the distance, is on the bottom of the fraction, so the distance is inversely proportional to the electric force. So if the distance is increased, the electric force will decrease. And by how? Well, the electric force is proportional to 1 by r squared, so which is inversely proportional to the square of r, right? So the force of the electric force will be equal to 1 by 2 squared which will be 1 by 4. And since the original force of repulsion was 100 newtons, this will be a quarter of 100, which is 25 newtons. So when we double the charges, the force of repulsion also doubled. But when you double the distance, the force of repulsion was decreased by a factor of 4. And what are the units actually? The unit of force is newtons, and the unit of the charge is coulomb, and sometimes you might be given microcoulomb. So 1 microcoulomb is equal to 1 times 10 to the power negative 3 coulombs. 1 nanocoulomb is, okay, this is 1 times 10 to the power negative 6 coulombs. And this is equal to 10 to the power negative 9 coulombs. Yeah. And the distance will be in meters. So if you're given centimeters or millimeters, make sure to convert them into meters. So this was all about the basics of the Coulomb's law. So see you in the next video.